Okay, so now they want you to add and subtract and multiply and divide. And I understand there are a couple problems on the test. And this is where people get a little bit twisted when they see it, because I go through it probably in a day or two in class, and it's not really computing in the head. So make sure you understand how to do these operations with scientific notation. Because if you have one on the test, I feel as though it might be an easy answer if you understand the steps, of course. So let me get my calculator. What I'm going to do for adding is I'm going to put them back into regular numbers, but they want it in a scientific notation answer. So let me explain. When you put this into the calculator, you can do 3.4 times 10 x to the y. Ugh. Sorry, excuse me for a minute. X to the y button and 7. So 3.4 times 10 x to the y button 7 and then hit equal. You're going to get 34 million. Make sure you hit the button or the correct buttons. And then for 8.9, you can do the same thing. You're going to do 8.9 times 10 x to the y button 5 and then equals. And the calculator that we use in class is the Casio FX260. If you use a different one for the test where you're at, then find the button that has the X to the Y button. I believe most of them have it, so look for it. But our Casio FX260 has it. It is the third row, and it is the second key in from the right. It's right above the clear and C and AC buttons that are gray on the calculator. And then you put that in, 8.9 times 10 to the 5th power, and it equals 890,000. And since this is to add, you're going to add those together. And that's pretty easy. I mean, 34,890,000. Now that would be the standard form. But they may want the answer in scientific notation. So to make it scientific notation, you just move your decimal over however many places to make this number, what? Greater than 1, smaller than 10, less than 10, right? So we're going to go 1, 2, 3, 4, 5, 6, 7. And I'm going to write 3 and 489 10,000ths times 10 to the 7th power. And this would be your scientific notation. And you have the ability to go back and rewind and look at it again and see what steps I took. So that's how you do that one. The next one, I think I chose the minus one, subtraction. I'll get it. Subtraction. And this one, we're going to have to do a little manually. You can't put negative exponents in the calculator. At least I haven't been able to do that. It's just easy if you do it by hand. 1, 2, 3. And I'll just rewrite the number here. Because it's a negative exponent, I'm going to the left. And then this one here, 2. And you can do that. And then you're going to punch it in the calculator just like that. 0.0044 minus 0.069 equals, and you have a negative 0 and 646 10,000ths. That would be your standard notation, standard form for the answer. But if they required the scientific notation, then you would go 1, 2, and you would say negative 6 and 4, 6. And you would do times, and you would do negative 2. And that would be your scientific notation. And the test is multiple choice, and you would see what answer they would need. Which answer do they want? They want it in standard form, or do they want it in scientific notation form? Okay. The next one is multiplying. This is a little easier. You can separate these and then multiply them, so that's what I'm going to show you how to do with these. You can do 2 and 1/10 times 6 and 5/10 times 10 to the 3rd times 10 to the 5th. And so this is where your product rule comes in for polynomials. And your product rule is to keep the base add the numbers, add the exponents, pardon me. Add the exponents. So you would keep the base, add the exponents, and it would be 10 to the 8th. And then over here, you would do 2.1 times 6.5, and it would be 13.65. However, there's a however. This is 13. That's more than 10. You can't have that number like that. You can't say 13.65 times 10 to the 8th. That number has to be greater than 1, greater or equal to 1, and less than 10. So I have to move that over one more to make it greater than 1, less than 10. However, that 1 that I moved, I have to add it to that exponent. So now I have to rewrite it, rewrite the answer. It's going to be 1 and 365 thousandths times 10 to the 9th power. And that would be your final answer. Don't forget to make that greater than 1, less than 10. And when you do that, you add that 1 to there. The next one is to divide. So you would take the 2, you would do 8 and 4/10, and you would divide it by 2 and 2/10. And then you would have, and you know what, I think we can change this multiplication, and then you could do 10, and you could do it that way. Now this is the quotient rule. Quotient rule in polynomial world, as I call it, tells you to keep the base. As long as the bases match, you keep the base. And subtract the exponents. 8.4 divided by 2.2 is going to be 3 and 80. We'll round it to the nearest hundredth because it's 3.81818181 and it's the continuing decimal. And then to subtract, we would keep the base, subtract the exponents, it's going to be 10 to the negative 3. And that would be the final answer. We don't have to change the first one because it's already greater than 1 and less than 10. So then I gave some examples. And here you can write them down, you can pause the video, and then see if you can do them on your own, and then you can come back and see if we got the answers right. So this one is multiplying. So that one, we just do 2.6 times 4.3, and then 10 to the third times 10 to the fourth. And we could just do it on our calculator. It's 11.18 times 10 to the 7th. Now what do you know? That's 11.18. What are you going to do? Change it to 1 and 118 thousandths. You have to move this over 1. You're going to rewrite it as 1 and 118 thousandths. 10 hundred thousandths, and then add that 1 that you moved to that 7, and now it's going to be 10 to the 8th. And that would be your final answer for that one. This one is adding again. So you could add 5.1 plus 4.8 and then do 10 sevenths times, or 10 sevenths plus 10, but it's so complicated to do it that way. Just change them back to regular numbers like we did prior to the sample. This would be 51 million. And then this would be 4.8 times 10 to the 6th, and that's going to be 4,800,000. And then add those together, and it looks like it's going to be 55,800,000. That would be your standard form. And then to change it to scientific notation, you move that over 1, 2, 3, 4, 5, 6, 7. Seems to be the way to do it, right? So this is standard form. And then this is the scientific notation. And then 2 more problems, and then we are done with the scientific notation lesson. And this one you're going to divide, so you're going to do 8 7/10 divide by 2, 4, and then 10 to the 8th over 10 to the 5th, and then I would do 8.7 divide by 2.4. Did I redo the problem that we had last time? I guess not. Okay. Subtracting the exponents, dividing the decimals. This is the final answer you get for that. Back together, and we come across this subtraction problem. So what I did is I worked it out. I did it the long, I went to standard notation. 9,300 minus 1,400. It's going to be 7,900. For the standard form, and then I'm going to turn it into scientific notation. 1, 2, 3, and so this would be the scientific notation, and this would be the standard form. And again, you check to see what answers they want. But there you go. And there you have it. So that's adding, subtracting, dividing, and multiplying scientific notation. Thank you. Have a great day.